Hi, welcome back to my class in Mathematics of Investment or Business Mathematics. For today, we will discuss the procedure or method for finding the unknown compound interest rate. And this procedure or method will make use of the properties of exponential and logarithmic functions. For our first example, consider the following. 50,000 pesos accumulates to 71,365 pesos after 3 years and 5 months. Find the rate of interest compounded monthly. As in other problem solving, we write first the information given. 50,000 accumulates to 71,365 pesos. That means 71,000 pesos is 71,365 pesos is the accumulated value denoted by capital A. $71,365 pesos is the accumulated value of 50,000 pesos, which means that 50,000 pesos is the amount of principal denoted by capital P. And 50,000 pesos becomes 71,365 after 3 years and 5 months. And that is our time denoted by T. But as I said in the previous lessons, whenever you make use of the formula, the time T should be in years. But in this particular problem, the time is given in years and in months. Thus, we have to convert months to year and add it to 3 years. In converting months to year, we make use of the following equivalent times. To convert 5 months to year, we make use of these equivalent times. 1 year is equal to 12 months. To convert 5 months to year, we multiply 5 months by conversion factor obtained from these equivalent times or units. And we write 1 year in the numerator and we write 12 months in the denominator so that months and months will cancel out. And you get 5 over 12 year. Hence, 5 months is equal to 5 over 12 year. Or you may convert 5 over 12 to decimal number, but you have to take all the decimal numbers because we will only round off the final answer. 5 over 12 is 0.416666. The digit 6 is repeated without n. Thus, we might as well use 5 over 12. So, we will not have to write 6 repeatedly. And we add 5 over 12 to 3 years because the time is 3 years and 5 months. We find the total time in years, 3 years plus 5 over 12 year, which is 5 months. And for 3 to have a denominator of 12, we multiply 3 by 12 over 12. And the common denominator is 12. And the numerator will be 12 multiplied by 3 is 36. 36 plus 5 is 41. Our total time in years is 41 over 12 years. We have the original 3 years plus 5 months in year, 5 over 12. We multiply 3 by 12 over 12. Common denominator is 12. Numerator is 12 multiplied by 3, 36, plus 5 is 41. And the required is to find the compound interest rate compounded monthly. The required is to find the compound interest rate or the rate of interest compounded monthly, which means that interest will be computed 12 times in a year. So the number of conversions M is denoted is equal to 12. And J is the compound interest rate per year. And the interest will be computed 12 times in a year. At compound interest rate, the formula is given by compound interest rate, the formula for computing the accumulated value of the principal P is given by A equals P times quantity 1 plus I to the power N, where N is the number of conversion periods, the total number of conversion periods, 40 years. And the total number of conversion periods, 40 years, if the number of conversion periods per year is 12, is M multiplied by T. For in our example, the number of conversion periods in 1 year is 12. And our time, T, in years is 41 over 12. And 12 over 12 will cancel out because it's equal to 1. And we get 41. The interest will be computed 41 times over the period of 3 years and 5 months, or 41 over 12 years. Small I here is the interest rate per month or the interest rate per conversion period, and it's given by the interest rate per conversion period. In this example, the interest rate per month is given by J over M. We write J because J is what we want to find in this problem. Divide by M, M is 12. Now we are ready to substitute all the given into this formula. Accumulated value is 71,365. Is equal to P principal. The principal is 50,000 pesos. Multiplied by quantity 1 plus I. I is J divided by 12. To the power N, N is 41. And we will solve for J from this equation. So for the J, or the interest rate compounded monthly from this equation, as in solving any other equation, the variable should be at one side of the equation, and the coefficient of this variable must be 1. In one side of the equation, we should have only J. So we start eliminating 5,000 by dividing both sides by 5,000. This is 50,000. Divide both sides by 50,000. And 50,000 over 50,000 is 1, or just cancel out 50,000 over 50,000. We have we should have the variable J at one side of the equation only. Next, we start by getting rid of the exponent 41, the exponent of 1 plus J over 12. And we do that by taking the natural logarithm of both sides. Take the ln of the right hand side, and take the natural logarithm or ln of the left hand side. At the right hand side, we apply one property of natural logarithm. This is the property of natural logarithm that we will use. Ln of x to the n equals m times ln of x. The exponent n of x becomes the coefficient. That means you can bring down the exponent of x as coefficient of ln. And we apply this property to the right hand side of this equation. Ln of quantity 1 plus j over 12 raised to 41 is now equal to the exponent 41 multiplied by ln of 1 plus j over 12. And the left hand side is the same. Next, we get rid of 41 at the right hand side by dividing both sides by 41, or multiplying both sides by 1 over 41. We multiply the right hand side by 1 over 41. And we also multiply the left hand side by 1 over 41. We multiply the left hand side by 1 over 41. We multiply also the right hand side by 1 over 41. And that's the multiplication property of equality. And 41 over 41 is cancelled, or is 1. Thus, the right hand side is ln of quantity 1 plus j over 12. At the right hand side, we have ln of 1 over 41 times ln of 71,365 over 50,000. But the variable j is still inside the natural logarithmic function. Thus, we must get rid of this natural logarithmic function at the right hand side. And we again apply a property of exponential function and logarithmic function given by this is one of the properties of exponential and logarithmic functions. E raised to ln of x is equal to x. It is because ln is a logarithm to the base e. So if you raise e to the power ln of x, e to the power ln of x simplifies to x. So we take the e of both sides, the exponential of both sides. We raise e to this power, e raised to 1 over 41 multiplied by ln of 71,365 divided by 50,000 equals, we take the exponential of the right hand side, e to the power ln of quantity 1 plus j over 12. And it is to the right hand side that we apply this property of exponential and logarithmic functions. E to the ln of x is equal to x. Thus, e to the ln of 1 plus j over 12 would simplify to 1 plus j over 12. It's like e and ln are cancelled. The right hand side by this property simplifies to 1 plus j over 12. At the left hand side, we still have the same expression, e to the power 1 over 41 At the left hand side, we still have the same e raised to 1 over 41 multiplied by ln of 71,365 over 50,000. Now we have almost only j at the right hand side. Next, we eliminate 1 from the right hand side by subtracting 1 from both sides or by simply transposing positive 1 to the left hand side, and then multiplying both sides by 12 to eliminate 12 in the denominator of j. We now transpose positive 1 to the left hand side, and if we do that, we would only have j over 12 at this side of the equation. And I will start from this side of the equation, j over 12 transpose 1 to the left hand side. At the left hand side, we have e raised to 1 over 41. Multiply by ln of 71,365 over 50,000. Now we transpose positive 1 to the left hand side and it becomes minus 1. And to eliminate 12 here, we multiply both sides of the equation by 12. If we multiply the right hand side by 12, 12 over 12 is 1, and we would get J. And the right hand side, we multiply by 12, or cross multiply. 12 multiplied by the right hand side. We have 12 multiplied by the left hand side. Now you compute this directly in your calculator, or you may use decimal numbers, but do not round off yet until you arrive at the final answer. I will start with this ln of 71,365 over 5,000. I will compute ln of 71,365 over 50,000 using calculator. You press ln, open parenthesis, 71,365 divide by 50,000. Close parenthesis, and you should get 0.3557. Now you should get all the decimal numbers. Do not round off yet because this is not yet the final answer. Now divide this divide your answer in your calculator by 41. When you get ln of 71,365 over 50,000, do not remove your answer in your calculator. This is the answer in your calculator, and divide that by 41. The answer in your calculator, divide by 41. This decimal number divide by 41, you should get this decimal number 0.0086776. You write all the decimal numbers from your calculator. Now we compute this difference. E to the power, this decimal number, minus 1. The minus 1 here is not included in the exponent of E. It is not 0.008 minus 1. It is e to the power 0.008. That value minus 1. you press the exponential notation in your calculator, e to the power x, and you press 0.008677671. Six seven one 8939 89. The value of e to the power 0.008677671893989 is 1.0087154320330 minus 1. So subtract 1 from this decimal number, you get 0.008. We have 1.0087154 minus 1 equals 0.0087154. 320, 330. And this difference, you now multiply by 12. And you should get 0.104. The product of 12 times 0.00871 is equal to 0.104585. This is the interest rate compounded monthly in decimal number. And to convert that to percentage, we'll multiply this decimal number by 100%. And that's the time you will round it off to 2 decimal places. We multiply the interest rate in decimal number by 100% to convert to percentage. And we get 10.45,851,843,9690456%. And now you round this up to 2 decimal places. If you want to round this up to 2 decimal places, you round off the third digit from the decimal point. From the decimal point, you count 3, 1, 2, 3. The number to be rounded up is 8. Since 8 is more than 5, we add 1 to the preceding digit or the digit that comes before 8, which is 5. Add 1 to 5, you get 10.46%. And this is the required interest rate compounded monthly. The amount of principal of 50,000 pesos accumulated to 71,365 pesos after 3 years and 5 months at the interest rate of 10.46% compounded monthly. For your practice, please try the following exercises. For each of the following, 23,900 pesos accumulates to 31,750 pesos at the end of 5 years and 9 months. Find the rate of interest compounded, A. monthly, B. quarterly, and C. semi-annually. For these three, A, B, C, you have the same given information. The original amount of 23,900 accumulates to 31,750 pesos. And for each of these three, you will find the interest rate, the compound interest rate, but the number of conversion periods per year is different. In letter A, the compound interest rate is compounded monthly. In letter B, the unknown compound interest rate is compounded quarterly. That means the interest rate will be computed 4 times in a year. And in letter C, the compound interest rate is compounded semi-annually, which means interest will be computed twice a year. And the time given is 5 years and 9 months. Again, you have to convert 9 months to year and add it to 5 to have the time in years. And that completes our lesson for today, finding the unknown compound interest rate. If you have a question about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalison, the channel of learning and leisure. Or you may ask your friends, classmates, and neighbors to subscribe to my YouTube channel, Art Kalison, so they may learn as well. Thank you for joining me in my class today.